Hello, ladies and gentlemen, and welcome back. We're going to be starting Part C on the... didn't mean to cross out the whole thing, I just wanted to underline it. We're going to be starting Part C on our 2014 Canadian Open paper. So what have we got? We have to keep in mind we need to justify things, write things down, and be very clear in what our answers are for the markers. So a sequence of the form T1, T2, all the way up to Tn is called geometric if T1 is some number, but you get each successive term by multiplying by this constant number r, called the common ratio. This isn't what they say, I'm just filling in some information about geometric sequences. They pop up a lot on contests. For example, 1, 2, 4, 6, 8, 1, 2, 4, 8, 16. Misspoke there. This is geometric because you just multiply by 2 each time to get the new term. And 1, negative 3, 9, negative 27. This also works. Something else, you could have 2, 6, 18. That's a perfectly good one, multiplying by 3 each time. So these are geometric sequences. In all three questions below, suppose that T1 through T5 is a geometric sequence of real numbers. Okay. So A part, if T1 is equal to 3 and T2 is equal to 6, determine the value of T5. Well, all you need is two terms, and you should be able to figure out common ratios. T1 is A, and this is, oh, what did we say? It's 3, and 6 was T2, and so that's AR. So T2 over T1 is AR over A, which is R, but that's 6 over 3, so R is equal to 2. And we also can see that A is equal to 3, and that's enough information to completely determine our geometric sequence. So T5, in general, and they even show us this in the question, your Tn, your nth term, is AR to the n minus 1. So T5 would be AR to the 5 minus 1, or AR to the 4. So that's 3 times 2 to the 4. So that's going to be 3 times 16, and that's going to be 48. So 48 is our answer for T5. I'd probably put it in a box like this, and there we go. So we move right along to B part. If T2 is equal to 2 and T4 is equal to 8, determine all possible values of T5. Okay. So we have, let's get some more space. So similar sort of thing now. We know that T2 is, it was 2, right? Yeah, 2. That's going to be AR, and 8 is T4, and that's going to be AR cubed. So it'd be really nice if I could figure out A and R. Now we've got two equations, two unknowns. In theory, we should be able to do this. However, 8 over 2, which happens to be 4, is AR cubed over AR is just going to leave us with R squared. So R could be 2, or it could be minus 2, and there's actually no way to figure it out. Now, if R is 2, A is T2 over R, so that'd be 2 over 2, which is 1. But it might also be that R is negative 1, and so A is, again, T2 over R, 2 over negative 2, we're looking at negative 1. So either A is 1 and R is 2, or A is minus 1, R is negative 2. And you can check both of those will give 8 and 2 in these proper positions. Now, what are we asked for? We're asked for T5. Well, again, that's AR to the 4. And that's going to be 1 times 2 to the 4, which is 16, or negative 1 times negative 2 to the 4, which is negative 16. So T5 is 16 or negative 16. Okay. Now you could figure out the R to the 4 from the R squared. We always knew we were going to be multiplying by 16, but the question is, what's the A? And so the A changes depending on what the R is. Alright, so now C part, more with geometric sequences. If T1 is 32 and T5 is 2, determine all possible values of T4. Okay. So same sort of thing. T1 is 32. So that's our A. We don't have to worry about that. And what was it? T5 was 32. Is just 2. So that's AR to the 4. What do we want? We want AR cubed, because that's T4. Okay. Well, it's not that hard to figure out what R to the 4 is. So 2 over 32 is AR to the 4 over A. So we get R to the 4. R to the 4 is 1 over 16. Okay. Now, we are told it's a geometric sequence of real numbers. So while you could get complex number answers to this, I would probably say something like R is a half, or negative a half, or I over 2, or negative I over 2. But this is if you know what complex numbers are. You would write this out and then say, well, AR must be real. So R is real. So R is a half, or negative a half. So that's one way to do it if you understand how to figure out fourth roots of things. Another way to do it would be instead to say something like, well, if R to the 4 is 16, then R to the 4 minus 1 over 16 is equal to 0. And you could use a couple difference of squares to figure this out. This one gives you roots of R's a half or negative a half. This one has no real roots. And then you could avoid writing down any complex numbers if you're uncomfortable with complex numbers. But either way, we see that we've got two choices for R, a half and negative a half. Okay, so each of those should yield their own sequence and their own T4. So we know what A is. T4 is AR cubed, so it's 32 and then a half cubed, or 32 and then negative a half cubed. So 32 times an eighth, or 32 times negative an eighth. So we either get 4 or negative 4. And those are all possible values for T4. Now, if they opened it up to complex numbers, we'd actually have 4 different options, but they quite specifically said real numbers. That's why I went back to double check. I don't think the Open will ever actually ask for complex number answers. Maybe on a C4 question if they introduce what complex numbers are, but certainly you should expect everything otherwise to be real. Okay, so yeah, that's all there is to say about C1, so we'll move on to C2, and I will see you for that in the next video.